afternoon, everyone. We are Team Mouse. So today we're going to present our final project, which is Global Health Analytics. First, let me introduce our team members. I'm the team leader. In this team, I'm in charge of front-end development and design and overall of the project. Followed by GHA Assistant Leader is our lead programmer in charge of the data processing. Then this is Jing Wei. It assists me for my front-end development as well as our report writing. And this is Jing Yi. He is our assistant programmer, assists GHA to do the data processing. And followed by Jing Hong, our data manager, who arrange and manage our data. So start out with our presentation. Let me first present a video for you. So I guess you have some basic understanding of project. So let me introduce my project to a very different way for you. So actually, we are Team Hours, and our project is called Global Health Analytics. So for this project, we actually cooperate with source, and it's meant to collect the big data and analyze them and display them in a website. So we're using a lot of different technologies. For example, high-peaks, Hadoop, and we gather the data from various sources. For example, PubMed, World Bank data, World Health Organization, and as well as the lifeexpectancy.com. Then, for our PubMed articles, we present the data into a bubble chart, which we will see later. So to display the keyword of the PubMed articles, so the user can really see the keyword clearly. And also, we have very different charts to display the healthcare workforce as well as the disease of the current global health. So, actually, this is our main page. We will see more later, followed by a very interactive format, which you can either choose by search by keyword or to click the country to process. So, the following pages are just some screenshot of our website. You will see more later.
So this is a user manual.
No.
This question.
So that's our agenda today. First, we already give us our product features overview. Later, Jing Yi will compare the things that we promised were done in phase 1 that we didn't, or the things we didn't promise were done in phase 1 but we did. And followed by a demonstration of our website in Linux. And we will discuss about how we're going to create a website and how GHA to do the PubMed article keyword processing, followed by a detail about website source code. And lastly is our product testing. So now I'll pass time to Jing to talk about.
Okay, so I'm going to talk about the before and after features that we have. In phase 1, we promised some features, but in phase 2, we didn't manage to. Some of them we didn't manage to do it, so we changed it. One of the features is our ranking graph. For that, we replaced another graph in our workforce page. Our comparison function is replaced with our PubMed bubble chart because the graphs are very big. So if we insert it inside, the thing will be too big and too long. So it will be not user friendly because the user have to keep scrolling down. Then furthermore, there's the workforce, which will later be shown. And the finance function, we change it to a network diagram because we are unable to find enough finance data. our login function and authentication function, right, we remove it because we don't find it useful. There's no point for users to log in. For the mobile application, we don't have enough time to develop, so we did not do it and remove it from our screen. So here are some of our additional features. For our home page, we add some additional CSS, and for the graph, we add visual effect and hover effect. For our PubMed bubble chart, the thing is to list down the keywords from the PubMed article and classify into categories. And the PubMed network diagram, they will show the connection between keywords and categories. Okay, now I'm going to demonstrate to you our website. So when user enter the website, this is what they will get to see. This is a simple description of our website. So under workforce, you can hover through the different countries and you can zoom in. You can click the country to display the graphs, or you can search them. So this is an example of our workforce data. So for this is our information that we collected from PubMed of some simple information about the countries. And this is our life expectancy by age. For this, right, you can see the different age and the life expectancy of it in percent. So the older the person is and the higher the life expectation is, means that the country is experiencing aging population. You also can see from here, this is the top 50 for our world life expectancy. Yeah, then user can scroll down to see more. Over here is our life expectancy over the years. With both, there are males, females, and both genders. And for this, it's the health worker and health facility of the country per 100,000 people. For all these, right, you can hover over to see the values. For the disease page, is similar to the workforce, where you can click or either search. So this is the cancer, the number of deaths in 2008 per 100,000 people. And here is the top 50 disease in Canada. And this is in the causes of death in the world, the top 50 as well. And here is the adult mortality rate for overall under 70 years old, under 60 years old, and per 100,000 people. And when you hover through, you can see the values. We also have a print function where users can print the graphs.
have.
So this is our PubMed bubble chart. So the blue one are the word count, there are more than 100. And the green one are the ones that are less than 100 but more than 50. And the grey one is less than 50. So they are the keywords from our PubMed article, and they can be categorized into different categories. And if you hover over, you can see the word and the number of times it appears in the article and the category of it. This is our network diagram, also from PubMed. This one, for this function, you can bring the words over and do comparison with other similar words. You can compare with them. Next is, because recently the trending disease is Ebola, so we did a simple function on it. So here are some of the informations that you can find on Ebola. Here are some of the graphs and the countries. When you hover over, you can see the dates and the cases and deaths.
Which is okay, back is there.
You really have those countries?
Yeah.
Yeah, the
Only
data
these countries.
countries.
Actually, there's more in the past. Actually, we are just analyzing on the recent trend of the Ebola outbreak. So it will be this
Only
big
this, yeah,
countries.
within these few years.
And here are other graphs on Ebola. Next, this is about us, the part of our website, and there's a short write-up of each of our members. Yeah, and there's a small description of our website. What is it about, and what you can expect from it. So next I'm going to pass the time to Gimtek to explain about PubMed.
Okay, please. Okay, so let me talk about our website creation overview. So since I'm the lead in charge of the data gathering, so let me talk about the data gathering part of the website. So in the data processing overview, we are actually consisting of two different types. One is about the graphs and charts. So in graphs and charts, we are actually collecting data from WHO data, World Bank, and World Life Expectancy. It can be really a lot of different formats like text files, CSV files. So these are the chart and graph parts. So on the other side, what you see is the bubble chart, which is the PubMed itself. So what we do, we are actually analyzing the trend of keywords inside it. So we will be extracting the articles, processing of keywords, and after that, you will actually do the cleaning, and after that, I will pass it to them to do the website. So since we know the demonstration of the design, you can see the whole thing. So let's go in depth about it, the PubMed articles. So normally when they talk about the trend of keywords, what do people expect? It's like popular, okay, let's say about Google search terms, like a top keywords. So what do people expect? It's like the humans, people, they're analyzing the trend. So they're actually analyzing what can be helpful or relevant for the society. So why don't we
apply the concept into our own global health analysis. They actually let the health researchers to actually research on something that is helpful and relevant for majority of the society. So we will talk about the data to be analyzing on. So what is the data that can be analyzed on? So first thing we come to our mind is PubMed. So PubMed, basically actually have the MedLine databases of the references, extract of the line sizes and biomedical topics. It's also one of the largest databases available for the analysis regarding to medical and health. Right now what it has is accumulated of the records up to 24 million. And every year they are planning to increasing by 500,000. So besides having one of the biggest database, we find that it's a really compelling reason to actually use PubMed articles because it's keep increasing. We are getting all the latest updates. So PubMed, there's a lot of tools. There are a lot of tools having on the website. There's like PubFocus, PubGet, PubAnatomy. These are the web tools. But if you're talking about computational tools, there's not really a lot more. It's like every single language, there's one program for it. So let's say Ruby, there's a Perl, BioPython. But in this case, since Python is widely used, we are using BioPython. So BioPython is actually a tool for freely available tools available for the to use like Unigenes, MedLines, and NCBI GenBank. And there's also MedLine. What they actually provide is a really free, convenient tools for them for programmers like us to actually extract the data out. So when you talk about extraction of data, you are talking about the data quality, what you're going to the data to be extracted from. So you're gonna need to consider about some of the quality measures, like what are the factors that can be taken in detecting your data. So me myself, we are also trying to figure out like what was wrong with the data, so we can actually make amendments. Like let's say the data is 0, so we expect that this data is not 0, it's just unknown. So we actually make amendments and changes. It's not really the most reliable method, but we think that it's the most important method. We also separate into small data. So let's say if we not sure if we are having mistakes or bugs in our code, so we just break down. So we just take a 1, make sure it's correct. So another thing is to ensure data quality, you can crowdsourcing, cross-reference, document and getting feedback is another one of the reasons why to ensure data quality from people from the public. So let me talk a little bit about the extraction of PubMed data. Right here, what you can see is how I extract using BioPython. So firstly, you need to have BioPython first. So after that, I will actually use the entrance features to actually search through the PubMed database. So I actually put in all the parameters right there. Terms, the amount of articles that I want to extract it from. So let's say if I want to make sure that I actually extracted, so I actually print out the amount of ID list. So these ID lists are actually the amount of articles ID inside the data. So to ensure that I actually have the records. After that, I will just convert into MedLine and I will just return the records. So as you can see, the return records, I will try to process it. So for every records, I will get the amount of the record keywords. So this is actually the content of records. There's a lot of things going on. So it's actually in JSON format. So what I want to do is just want the keywords. So maybe in somewhere right here, I actually see like there's an OT. OT is like a keyword. So I will just record get OT. As you can see, these are all the keywords for each articles. So I just put it right there. So every keywords I will just try to process it and store it into a list. So processing of the accumulated keywords, what we do is, once we have the list inside, we want to make sure that all those similar keywords, we will add up all the counts together. So what I do is I will measure the terms and the conditions in order to add up all the similar words together. So this is like a testing. So let's say like apples, oranges. So let's say apples are together, I will make sure they add up. So this like what I can do with it, so to make sure it's correct. After that, I will actually sort the results. So I just insert into it. So these are actually some of the real life results. So it's like the keywords obesity, diabetes, mortality are some of the top 10 searches in the PubMed history. Alternatively, we can also use the text block. So if beside the keywords, I also want to analyze on almost all the keywords in the article. What I can do is I combine all the contents into a string. After that, I use text block. Text block is a very simple, simplified text processing to actually process the data. So it's like, so let's say if I have a string, I will just put text and I extract all the texts. So after that, all the results. So besides using pigs, we also think about trying to provide more diverse kind of programming in our project. So we actually think about using user-defined functions, which is including extension supports like Java or Python. But definitely most of the supported languages is Java. So we are actually also using Java in our...
Can I just interrupt? How many records do you actually pick up from PubMed for your project? Because it cannot be just apple, orange. Yeah.
No, this is not. Actually the result, right, something like this right here. So this is like the amount of year, which is a trend. So let's say that year, the amount of words that I actually collected.
This is after you put it into MySQL. The raw data, how big is the raw data?
Raw data.
Yeah. Your records, the Python script, you have a records object, right?
Yeah.
How huge is that?
Really huge. I'm having a lot of problem like the storing error, so we try to optimize it. I think it's around like few MBs, more than few MBs. I'm not very sure. Okay, I'll come back to that. So, PIC user-defined function actually provide extensive support for custom programming and the common languages for such as Java, Python. It actually, so let's say if you are familiar with Java, you will actually use it for your preferences. So I just cut it short. So let's say I have a folder right there. So I will just create a folder for user-defined function, and I have list of files like this. The pick jar, so it generated pick jar, populate Java, compile it. Okay. So after that, I would like to end my presentation. Let me pass it to Bing Bing for the next one.
Thank you, Jing Ted. So Jing Ted talked about how he processed the PubMed article keywords. Now we're going to talk about how our website, how our D3 graph get the JSON from MySQL. So firstly, we have a web page. So actually they will pass a country name string, as you see when you need to select country before you can process the next page. So after that, right, the next page, which contains a graph, we'll call the PHP page. The PHP page will have set or act queries, so they can execute the query from MySQL to get the result back and format them back as a JSON file after they pass back to this graph. Each graph will have an individual PHP processing page. This is the most common way people do for the dashboard and drawing for D3 data. So we identify any other ways to do this. So this maybe for a reason is the only way. So yeah. So after they receive the JSON data, we display the graph. So now talk about how you pass in the data. Some of the data we get from internet is in Excel file or is in CSV file. So we need to store this file inside our Linux machine, virtual machine. But feeling that actually there's really some hard stuff when you want to store CSV file into MySQL in Linux. Firstly, you need to clean the file, very clean. Then they have 3 different formats in Excel to store as a CSV file. One is command, and this is Microsoft Doc. And the other one is Mac version. Actually, this is wrong. So save as a Mac version is not MS DOS. So actually, you can move the file into Linux. You can see it's different to formatting. First one, this is saved as a Mac format. Then they only show the first line of the data. The second one shows the full line of data. Usually, this type of data is very hard to store into MySQL. They sometimes will have the difficulty to read the data. So after you clean the data, you need to copy this one into the MySQL store directory. If not, you only can use, after that you only can use local data but local data is not really what we want. We want to store into server. So you need to copy the data to the MySQL directory. After that, right, after you create the dashboard and the tables, you can now load the data line by line into the MySQL. So it terminates by a comma, and line terminated by R. Some of the file is terminated by \n. So after that, you need to select the first attribute of the data, because sometimes they will consider the first attribute of the data as a primary key. So that means the processing node, right? So after that, as I mentioned just now, each data graph will have a PHP page. So how you're going to call the data from SQL is, firstly you need to format the PHP page into will return a JSON file, and I will receive a country, the string from the previous page, and after that I will connect to MySQL and execute the query to get the result. After I get the result, I need to format the result into a JSON file and return back. So the graph actually can draw the based on the JSON file returned. So next I'll talk about the PubMed article keyword bubble chart. Just now we can see the false chart that will combine to the center when in the overall tab, and the other one will be classified. So actually how it's done, first you need to do two switchable buttons. For ours is in Bootstrap style, because it's easier to use, and some JavaScript inputs. So the other one is very special, is you need a CoffeeScript. For the example I get, they use a CoffeeScript, a separate file. So this is to call the changes when the button switch from the CoffeeScript. So next, move on to the CoffeeScript. So for CoffeeScript, you need to call the data. It's a CSV file. We didn't store it into MySQL because we feel that we didn't really need to do selecting stuff in MySQL, so we just put it as a CSV file. So you need to get different things, for example, the category and the group. So the category is the things that will differentiate the keyword to different category. The group is the number of high frequency, medium frequency, and as well as the low frequency to draw the color from the bubbles. So as you can see here. So for our article, right, we have really different stuff that we need to consider. So actually you just now see the bubble is moving in and moving out, which is different two set of bubbles. First, because when you analyze the PubMed article keywords, when we analyze it, some of the keyword may appear in two different categories. So in overview, we want to combine these two in one single bubble. But in by category tab, we want to separate this one into two different bubbles. So it's very hard to separate a bubble, so we just join two different bubbles. So when you first click on the overview, so the overview is the categorized things, the categorized data will move out. So width minus by 0.8 will move out of the box, while the overview data will move in and combine into a very big circle. So the other one, the same goes to for the next page by categorize. So the overview will move up and the categorize will move into their individual places. So this is how in CoffeeScript the circles move. So you can see just how we define the movement. Now we need to call the movement to make the bubble move. So now I'm going to pass the time to Tim Wei talk about our workforce functions.
Next, I will go through about the workforce data. This is the first chart in the workforce page. It's the life expectancy by age, right? And this is the screenshot of how the thing looks like. This is a sample JSON file that we use to create the graph, each of the graph. So the code, right? For this, right, because as you see, there's two lines here, right? Then each of these defines one line each, and it returns a different value as the Y function. One is the male and one is the female. And the next, this is the domain for this axis. And as this domain, there's a minimum and maximum, right? Since our CSV data, there might be a lot of data with a largest value of like maybe 10,000 and another value which is like 100. We cannot like expect it to fit into the y-axis, right? So for the minimum, right, we need to like create a function that returns the d